Hello, everybody. Welcome to Math Lesson 1.3, Doubling the Number of Cubes. All right, so we're going to be talking about some dimensions today, which we've been mentioning for the last couple episodes, or videos, I should say. And dimensions, or what we're talking about there, is the measurable length of an edge of an object. So we've already had some experience with dimensions, but now we're going to be looking at them a little bit closer. So, for example, when we're looking at dimensions, here is a box that I made. Okay, the dimensions of this box are going to be the different lengths on the edges of it. Okay, so this one is 3, there's 3 right here, by 4 by 2. So here's the width, that's 3, the length is 4, and the height is 2. Okay, so I can write that like this: 3 by 4 by 2. And if you'll notice, when I'm reading this, I say the word by here instead of times. Okay, when we're finding the volume, we are going to multiply these, but when we're just saying the dimensions, we're not going to say 3 times 4 times 2, because that's actually a problem that we need to solve. When we say 3 by 4 by 2, that's telling whoever you're talking to that you're talking about the dimensions of something and not about a multiplication problem. All right, so we're going to be using these dimensions with this box to solve a problem. Now, for this problem, the order doesn't matter. I can say 4 by 3 by 2, 2 by 4 by 3, doesn't matter, just as long as I have all 3 of those numbers. I could do the height first, I could do the width first, I could do the length first, doesn't matter. Okay, I just need to make sure I have all 3 of these numbers, a 2, a 3, and a 4 in my problem. Okay, now, using this particular box and these dimensions, so the packaging factory wants us to build a box that holds twice as many cubes as this one. So this is what we already have. We need to decide, how can we build a box that will hold twice as many cubes? All right, now there's a couple ways we can do this. What I'm going to do, so I have 3 by 4 by 2. Well, if I need to make sure that my new box can hold twice as many, I need to find out first how many this can hold before I can find out what twice as many is. So 3 by 4 by 2, I'm going to go ahead and multiply that out. 3 times 4 is 12. And then times 2 is going to be 24. All right, so let's see what that's going to get us. Okay, sorry everybody, I gave you the wrong numbers for that one. So this is our example box, and it is 3 by 4 by 2, but the problem that I was trying to read about the packaging company is actually for a different type of box. So let's ignore this part right here. Okay, the volume of this box would be 24, but we're actually going to be looking at a different box. Okay, so this one is going to be, give me one second. All right, this one is 2 by 3 by 5. Okay, this is the box that we are working with now. And this is what the packaging company wants us to double. So I'm going to do the same thing I started doing here. I'm going to go ahead and multiply this out and figure out what my first volume is of this original box, so I can figure out what double would be. All right, so 2 times 3, that would be 6. And then times 5, that would be 30. Okay, so my initial volume is 30, which means if I want to double that, I know 30 doubled, or 30 times 2, or 30 plus 30, however you want to think of it, 30 doubled is going to be 60. So my goal volume is going to be 60. All right, so now what I'm going to do is, up here, see in this original one, I did length times width times height, or you could do height times, doesn't matter which one's first, but one of these is the length, one is the width, and one is the height. So what I'm going to need to do for this one is I'm going to need to find 3 numbers, one length, one width, one height, that when multiplied together are going to equal 60. Okay, so there's a couple ways I can do that. Let's see, first one I'm going to do, I'm going to try and get to 30 first, and then just double that. See, well, Yeah, I don't know, let's try one of these. I could do, let's try this. 3 times 5, okay, that's 15. If I doubled that, I'd only get 30, but if I doubled, so instead of multiplying by 2, I multiplied by 4, 15 times 4, that would be 60. Okay, so those are 3 dimensions that could get me to my volume of 60. I could also do 6 times 5, that's 30, and then double that. That would be 60 also. I could do 3 times 10, that's 30, and then do that times 2. Again, that would equal 60. I could do, use some bigger numbers. 2 times 15, that would be 30, and then times 2 equals 60. See, I'm trying to make this simpler on myself by using facts I already know and then either doubling them or maybe doubling them and getting up to 60. But either way, I'm using 3 numbers, 3 dimensions that when multiplied together are going to get me the volume of 60. Okay, so now that we have a couple examples here, I want you to look at some in particular here. Look at these 3. Okay, these 3 dimensions that we got to equal 60. Okay, now if we compare these with our original dimensions, so the original dimensions up here equaled 30, right? And it was 2 by 3 by 5, right? Now if I look down here, I have 3 by 5 by 4. Okay, well, 3 is in my original one, 5 is in my original one. The only number that's changed is the 2 turned into a 4. Okay, so that's something to look for. Look at that 4 was originally a 2, but when I made it to a 4, my volume was doubled. Okay, how about this next one? 6 times 5 times 2. Okay, well, a 6 is different than the original one. There was a 3 here, and when a 6 is doubled, it becomes when a 3 is doubled, it becomes a 6. But I did have a 5 in my original one and a 2 in my original. So I kept 2 of the numbers the same, I doubled one of them. And then this last one, 3 times 10 times 2. 3 is in the original one, 2 is in the original one. The only number that's changed is the 5 became a 10. And again, that's doubled of what the original number was. Okay, so it looks like in each one of these 3 options, I doubled one of the dimensions. I doubled one of the dimensions and my volume doubled. Now, if I was approaching this problem for the first time, I would think that if I'm trying to double my volume, I would want to double all of these numbers. But if I doubled all of them, if I did, so 2 doubled would be 4, 3 doubled would be 6, 5 doubled would be 10. If I did that, well, 4 times 6, that's 24, times 10, that's 240. That's way too much. That's way more than doubled of my original volume. So what I'm looking at here is that it only takes one dimension to be doubled to double my volume. Okay, now let's look at why that is. Let's look back at my original example prism. Okay, so this one, which we looked at the beginning, was 3 by 4 by 2. Okay, let me write those down again. 3 by 4 by 2. Okay, and we already multiplied that out. 3 times 4 is 12. Times 2 is 24. Right? So my volume of this prism is 24. Okay, now watch what happens. Let's see if I can get you guys the best angle for this. All right, so here you can see all my dimensions, right? Here's the 4 on this side, the 3 on this side, and the 2 in my height. Okay, now watch this. If I take another prism exactly like this one, and I put it on top, now they're not going to line up perfectly because these are paper boxes, and I'm not an expert taper, but they're close enough. Okay, look at what just happened to my box. My 4 dimension down here did not change. I didn't suddenly have 8 coming out this way. I still have 4, right? This number is still the same. My 3 side did not change. It's still 3. This one is 3. This one is 3. There's not suddenly 6 sticking out on this side. There's still only 3. The only number that changed was my height. My height was only these 2. Now my height is 2, 4. So my height doubled. My length and my width stayed the same, but my height doubled, okay? And now look, I took 2 of the exact same prism and put them on top of each other. Well, that means everything that's inside here, the volume inside this plus the volume inside this, if they're exactly the same, the total volume is going to be doubled. And all I had to do was double just the height. That's it. My length is the same and my width is the same. All right? So keep that in mind as you are working on tonight's homework, and make sure you're showing multiple ways to represent a volume that they're looking for, or maybe even a doubled volume. All right? Okay, good luck, everybody. Make sure to ask your teacher if you have any questions.